Hi everyone, I'm going to show you how to do some exponential growth and decay problems, specifically writing an exponential function representing either growth, decay from a table. Alright, so we'll start with this one. The number's a little more clean, that's why, a little easier to read the table. But we see here we have a table representing our x and our y values, and it's growing. We can see that because the y values are increasing. So we can tell already that this is not linear. Why? Because it's not growing by the same amount each time. Meaning, like, we're not adding some number each time, and it's not staying consistent. So, for example, we go from 3 to 9, you're adding 6. From 9 to 27, you're adding 18, right, and so on. So this would be a representation of an exponential function. So an exponential function is in the form y, just let me write it out. Y equals a times b to the x power, where a is our initial value, and this can be found by locating the y-intercept. And b is our common multiple. So meaning the number, that you're multiplying by each time to get to the next number on the table. So we're multiplying by some number, and to get to each, successive term on this table. So there's a couple ways you can do this. You can either think, what do I multiply 3 by to get to 9? What do I multiply 9 by to get to 27, 81, so on. So some of you might be able to see that immediately. 3 times 3 is equal to 9, and then you can just test it. 9 times 3 is 27. 27 times 3 is 81. But a trick is, if you can't immediately figure out what that common multiple is, just take one of the y values in the table and divide it by the previous y value. So I'm just going to say the b value for this table is equal to 9 divided by the previous y value, 3. And I can see I get 3. So I'm multiplying by 3 each time to get to the next number in the table. So I've figured out what my b value is, and then my a value for the equation, for the exponential equation, is going to be the y-intercept. So the y-intercept occurs where x is 0. So in this case, it's this first number that we see in the table, 0, 0, 3. So that's my y-intercept. So my a value is, in this case, 3. The y value where x is 0. So now I just have to put it all together to write my equation. So y is equal to a, which is 3, times 3 to the x power. So I can find any term. So this function represents this table, and I can find any term using any given value of x. So what I mean by that is, like, I could if I wanted to figure out what the value of y was when x is 5, I would plug in 5 for x. If I wanted to find the value of y when x was 7, I plug in 7, and so on. Okay, so that would be an example of exponential growth. So let's also look at one that represents exponential decay. So this table we could see is decay. And I know that because it's decreasing. The y values are getting smaller as x increases. So I'm going to do this the same way. I'm going to start by locating, what my decay rate is in this case, or what my, common multiple is. So I'm just going to take two of the values. In this one, it's kind of a little bit more difficult to just look at this table and figure out what it's being multiplied by to get to the next term. So in this case, dividing is probably going to be the best way to do this. So I'm going to just take one of the numbers in the table, let's say 0.005, and divide that by the previous y value, 0.01. So 0.005 divided by 0.01 is 0.5, right? And that makes sense because it is decay. And I didn't write this earlier, but if the if the b value, sorry, not the a value, if the b value is greater than 1, we have growth, exponential growth. And if the b value is less than 1, we have exponential decay. And in this case, right, it's less than 1, so we know this is exponential decay. I could also tell that it's exponential decay because the numbers are getting smaller. And I know, obviously, it's not linear because it's changing each time. All right, so we have our b value, our common multiple. We need our a value, which again is going to be, in this case, the first value we see in the table where x is 0. So a is equal to 0.01. We just put all this information together now to get y is equal to 0.01 times 0.5 to the x power. Okay. Let me know if this video is helpful in the comments. If it's not, let me know what I could do to better explain this, and I hope this helps.